Next is Hanna from CorPower Ocean. So we're talking wave energy now.
Yes, so give me 1 second and I will share. It's sharing as should.
Looks good.
Very good. Well, thank you very much, Linda, and very interesting to hear from Olof and Henrik previously also. Now we are off to something quite different. We're going to go offshore. We are going to dive into our oceans and talk about wave energy. So I'm Hanna and I represent CorPower Ocean as our head of people. For the past 6 years approximately, I've had the enormous pleasure of building our team. And today we're about 65 team members, an extremely dedicated and talented force we have at hand, where everyone is working so hard in bringing a new source of renewable energy to market. We were founded back in 2010, so we are getting a little bit old almost. And today we have offices in 4 countries in Europe. And since start, we have been quite successful in securing funding across Europe, where we have secured about 60 million euros to date. So what about wave energy? Well, it represents a huge opportunity. The oceans can really be seen as a large battery, and they actually form one of the largest untapped sources of renewable energy on Earth. The ocean waves could contribute to about 10% of the global electricity need. But as we have already heard, when looking at the energy market today, it is not enough just to generate green electricity. It's also a question of when you generate the electricity. Solar energy and wind energy are great, but they will only take us so far. There are gaps when it's night or when there is no wind. And when looking at wave energy, we can see that it has a very consistent and highly predictable production profile. And this is a new way of complementing the market, providing more stability and also reducing the cost for storage. And as we've already mentioned, I think we've all felt the peaks in electricity prices recently. It's been quite costly. We've also heard about corporations like Google announcing their 24/7, meaning at every minute of the day, to be able to use fossil-free energy. This goes exactly along these lines, that the timing of the generation of electricity is really important. And now, I'm not going to go into details of any graph here, but when looking at wave energy, together with the sun that you can see up and down day by day, and also the wind that is quite unstable up and down. When adding wave energy to the market, it does create a lot more stable supply. So demand and supply will, to a much larger extent, have the same timing. And this is really key going forward. So why is there no commercial wave energy on the market today? Well, it is easier said than done. It's very complicated. The oceans are an extremely tough environment. Historically, wave devices have either broken down in storms or not produced enough electricity to represent a business case to be cost effective. And CorPower is on a very good path of changing that. In our technology, we are focusing on the key aspects of survivability, of high efficiency, and also a lightweight device. And this is all in order to maximize the average annual load or the generation. So here's an illustration and a true image of our device. I said that it was lightweight. It's still about 60 tons, so it's not that small. But in comparison to previous devices that have been over thousands of tons of steel, 60 is really quite small. And by getting a large amount of energy or electricity from a small device, that significantly reduces all the material costs. The production footprint goes down, And it also brings down the operational costs in terms of installation, service and maintenance, and so forth. I'm going to just share a few words on the technology. But as you can see, we use a floating device that is attached to the seabed with a pre-tensioned mooring. We use a unique method that is called phase control that makes our buoys oscillate in resonance with the incoming waves. And thereby we can get a large amount of power absorbed with a small device. And this is really where we have the efficiency. Now, survivability is also key and has been one of the largest challenges so far in wave power. And just as we can amplify the movement of our device in the water, we can also turn this function off. And thanks to the transparent design of the device, it becomes resilient to the toughest storms, so it doesn't break. And this is the same function when looking at wind turbines when they pitch the blades in order to protect the system from overspinning. And with this technology that we have seen, our devices can deliver up to 5 times the energy per ton device at a third of the cost. And this together all really boils down to a cost of energy that will be able to compete with offshore wind as we climb down the cost curve. So the question then is, how far have we actually come with our development? Well, quite far. Already since start, we have been very scientific and we have followed a step-by-step validation of these key concepts, survivability, performance, and economics in order to ensure a valid business case, all from the small scales back in 2012 up until the world's first active wave farm connected to the grid that we are foreseeing in 2024. But today we're 2022, and here's where we are. So here's our first full-scale device. This is from our facility in Stockholm, where we are at the moment finalizing a very extensive dry testing program. And this dry testing program is also quite unique to our development. It's all about taking a step-by-step approach. Simultaneously to these activities in Stockholm, we have our team down in Portugal who are working on winding the composite hull. And this is yet another innovative process, probably worth a completely own presentation. But later this spring, these two will come together and they will be installed in the ocean outside the coast in Portugal. And later in 2024, at the same site, is where we will install 3 more devices to demonstrate the concept of a small wave park or wave farm. And it's also the wave farm that is the actual product. Each device that is included in a farm is rated at 300 kilowatts. At this point. And with this illustration, you can probably see that it's in the ocean, it looks like a quite small device and it does not ruin anyone's view. All in parallel with this technical development, we have been working really hard since several years on building a pipeline of products developed by customers, all to ensure a structured and effective commercial rollout in 2024. And already today, and since quite a while, we are collaborating with some of the largest utilities in Europe that are showing great interest for this new technology. So we are working with Iberdrola, EDP, Enel, and so forth. So CorPower, to conclude, we are looking at a really exciting 22. We're hoping that the winds will be with us in the ocean. And I also really hope that you will join us on our social media channels to stay tuned. And please reach out to me if you have any questions. Unfortunately, I won't be able to stay after the presentations, but I am fully available for questions afterwards.
Brilliant. Thanks a lot, Hanna. We got one question here. We got two questions. First, do you have the manufacturing line set up? But I think you gave away half the answer in your presentation.
Well, yes, we're working very closely with our suppliers. The composite hull, which is one of the parts we're actually doing ourselves with a new technology where we have a mobile factory that we will be able to move around, and to move that around is a lot easier than the actual product that is 9 meters in diameters. Whereas the PTO, or the inner part of the device, we can put it on a truck to transport it across Europe. But yes, we are working closely with the supply chain on this.
Thank you. I have a second question here. What's the average output in kilowatt in Portugal, or in annual production per unit, or capacity factor?
Well, one device is rated at 300 kilowatts. So then, of course, a park depends on how many you add together.
Thanks a lot. I got, out of curiosity, does this have anything to do with Stig Lundek's innovation? And I can already say yes to that.
Yes, yes, very much so.
It's not the only spin out of Stig.
No, this is definitely a spin out of Stig, and it started back in 2010 with the initial concept that is based on the principles of the pumping heart, of the human heart, actually. So it is quite an interesting story. Since then, obviously, the technology has developed and modified a bit, but the origins are there, and it's all honor to Stig and his entrepreneurial mind.
Thank you very much, Hanna. Sorry that you can't stay around, but I'm sure that we will. People can contact you directly if they have questions afterwards.
Absolutely.
I'll say hi to Patrick from me.
I will. Thank you.
I got one more actually. Let's see if Hanna. Yeah. Just now, in the map you showed areas along the oceanic coast. Is there a potential application in the Baltic, Mediterranean? So do you need big lakes or small lakes?
No, not really. Where we're seeing the biggest application is mostly along the west coast, and that has to do with how the earth is spinning and how the waves are coming. So it is in mostly along the west coast. So we have the whole European west coast, we have the US Atlantic coast, and so forth, or the US west coast. Not so much the Mediterranean.
Thanks a lot, Hanna.
Thank you.